When you do a rates of reaction graph, you get a curve that occurs like this because the reactants are less, and so there's less collisions, and so the reaction slows. So the initial rate of reaction accounts for changes in temperature and concentration of reactants and gives you the most accurate rate, whereas the average rate is always less. There's a very unique situation, however, with thiosulfate in that they actually have the opposite curve, and instead of curving off like this, it's sort of inverted, and the rate of reaction actually increases with time. And so it's an exponential increase. And so this occurs because there's an increase. You can see from some of the journals that explain it that because the reaction between HCl and thiosulfate gives sulfur particles. The more sulfur particles there are, the increased surface area for there to be collisions, and so it's easier for new sulfur to form. And so what you have here is these industrial rates of reactions are actually less than the average rate of reactions. And you can see from this data that they are increasing with increasing thiosulfate concentrations. And then they reach this plateau at around 300 and something. For this particular experiment, the machine goes up to about 1 or 2,000. So if you do an actual rate equation fitting of best line, you get 1.4, which seems to be correct. There's lots of literature out there. This particular one that has analysed it, it says it's about 1.5, but they're not quite sure. It's pretty crazy. Dr. Brown says that it can be 0 to 1, but it depends. That's the most commonly quoted, but it depends on the relative concentrations of thiosulfate acid can actually affect the rate order. So it's quite a mess, but 0 to 1 doesn't really fit that one, but this one, 1.5, it's quite close. And so that is quite acceptable considering it's probably correct considering the conditions that it was under. Okay, so just thought that would be of interest to you, that what you think is these normal rate curves can be quite bizarre. So you're normally controlling for temperature and mostly important reactants by doing initial rates. But with thiosulfate, you're actually controlling surface area because surface area is out of control if you take initial rate.